So this is my modified circuit for the ATS switch. I purchased an ATS switch off of Amazon, which it's only rated for 10 amps, and my application, which is to use it to switch between two batteries on an e-bike, is generating very close to, if not more than 10 amps, so it would often melt out the components on the original ATS switch. So what I've realized that I can do is I can use the original ATS switch from Amazon that I purchased and use it as just a trigger and a sensor. In other words, it's going to see the voltage coming from battery 1, voltage coming from battery 2, and be able to know which one to activate. Battery 2 being the backup battery. When battery 1 goes down or is not being used, it'll switch to battery 2. If battery 2 is plugged in and battery 1 is plugged in and battery 1 has enough electricity, it will switch it to battery 1. When battery 1 gets low and shuts off, battery 2 will kick in as the backup, and they'll just go back and forth. So you've seen my other videos, or you should have seen my other videos on how the system works. So what I've done is I've replaced the blue relay that normally comes on this board. That blue relay that normally comes on this board is where the limitation of 10 amps is. I've upgraded to this puppy. You see the numbers right there. It's an SLC with a CL-C. I think that's a DSVD. I don't remember. It's kind of rubbed off because I've been doing a lot of stuff on it, where I can run the electrical components from the top, and this is a 30 amp relay, more than enough for running my 36 volt system, which is 42 volts maximum when the batteries are fully charged. So what I've done also is it usually has these little blue pins on here that you plug in your adapters. I got rid of those because those are weak points also, and wired directly to the board. What I did after removing the relay is it's no longer using the board original for running the switching. I'm taking the switch trigger, running it into this relay, and that's 5 volts basically is the switch trigger, and that 5 volts is going on the coil. You can see in there I've inserted a little diode so it doesn't switch back. So the original voltage switch trigger is these 2 points here. I've taken those out. I've had to switch directions because of how this is placed, and what I did was add a second board to it like that. So the original 5 pins, 1, 2, 3, 4, 5 pins, which was the original relay, that relay is now removed. I'm using this one and this one, which is my coil output of the 5 volts, and I'm running that to the coil input 5 volts onto my new relay, which is my 30 amp relay, and I've got the diode across the relay to make sure it is not going to kick back any electricity and make sure it keeps everything in the proper direction and not cause a short. So now what I end up, this one, when I design stuff, I like to make it repairable or workable, so to speak. So there's a lot of connectors on here, but if you want to hardcore just wire this in, go for it. I use connectors so that I can take it apart and change out components as I deem necessary or as need to be done. So it's got connectors here so that I can disconnect the positive from here for where it plugs in. So what I have on my circuit, I have the common, the little clear, that silicone, electronic silicone that I use to help protect surfaces and also to help keep my wire steady so that my wire is not just flopping around. It's helping to give that a little extra stiffness in place. So that's the silicone glue that I use as an electronic glue. I do that also here, and I've got a connector here for the negative. So all my negatives come to a common point, which is here. That's my negative from my main battery, negative from my backup battery, negative going out to the controller, and here the negative, which has to feed the board in order to see electricity to trigger it. All right, my positives are my red and my blue in this particular circuit, which is going to come from my battery 1 or my battery 2. On the opposite side of it, I have my outputs, which is just going to be my reds going to the typical XT60s. And I have that kind of inserted in there. These are components that I got from the hardware stores. This is a 1.5 inch end piece that I've heated, flattened out, stretched it out, and then carved into it in order to put my plug pieces onto the end of it. This is a little piece of aluminum tubing. I went and used the aluminum instead of PCV or PVC, whatever, so that it'll kind of have a little bit of a heat dissipation. I know the board is not attached to the aluminum, which would help a lot more, but with the air flowing past here as he's riding the bike, it'll keep the aluminum cool, which inadvertently will keep the air inside cooler, which should keep this cooler. But I really shouldn't have my heating problem that I was having before, because with this 30 amp relay on it handling all the actual electrical transferring, I really shouldn't have any issues with heat whatsoever. I've got this little silicone here because as I made the joint for it, there's a little bit of exposure, so I just put a little silicone over it to make sure it doesn't touch the aluminum when it's going inside of the fitting. Over this piece right here where the joint connectors are, I just put a little piece of electrical tape. I took all the electrical tape off for now. A little bit of electrical tape, and for a little extra, I actually wrap this whole thing in electrical tape across the bottom. Again, this is mainly just to prevent any shorts from when it's inside of the aluminum housing here. So I have my two right now are unplugged, but basically I did it with the shrink tubing because with shrink tubing I can make angles and it's less space since I'm using a smaller space. If you have a larger housing that you want to use, you won't have to worry about any of these little extra things. You can just, you know, do it and let the wires go wherever they may. So in my normally closed, which you can see an NO and an NC, in my normally closed circuit, I have the main battery from below. In my normally open circuit, I have the backup battery. So I'm going to plug those back in real quick. Sorry about that. It's a lot faster for you if you have two hands. So I prefer this, and I've said this before, so in case you haven't seen my other videos, I prefer this over using a battery blender, because a battery blender is looking at, I've never used it, so this is an assumption for me. A battery blender is taking two batteries, connecting them probably in parallel so that the voltage stays the same, and the current is what you're basically multiplying by having two batteries, and it's going to allow your bike to use both batteries, which means it's a longer time before you run out of electricity. But here's the deal. I've read that with the battery blender, you got to make sure both of your batteries are charged up fully before you use it. In other words, you got to have the same electricity approximately on both batteries. Not that big of a deal, but what about in the case where you only want to use one battery instead of both batteries? You could probably still run that blender, but then now you got to wait until you have that one battery charged back up before you can go back to using two batteries. And you got to make sure that both batteries are charged up fully before you use it on your bike. That's what is being said, and it makes sense to me in this particular way. If you have one battery going and the second battery plugs into it, where am I other? Oh, you have a second battery plugged into it, and that second battery, whichever battery is at a lower voltage, when they're plugged in parallel, the extra one, the one that has the most power, is going to drain off into the one that has less power until they have equal power. To me, that's a waste of electricity while it's trying to do that. I would rather either battery work at either voltage and just go to the bike, go to the motor. So my ATS switch, alternate automatic transfer switch, does that for me. It doesn't matter what electricity my battery 1 or my battery 2 is at as far as power. it'll just run it. The batteries themselves have BMSs built into it to keep their systems all in balance. It automatically shuts off at a certain electrical point for that battery. When that shuts off, this system will see that it's shut off and just simply switch to the other battery. It doesn't need both batteries. It doesn't need both batteries to be charged up fully. It simply switches between whatever battery has the electricity running through. If it's the main battery, it'll keep it on the main battery. If the main battery has not any electrical output, it'll switch to the backup battery. Simple as that. And this allows me now to have two batteries on the bike, or one battery, either one, plugged up and go. Whenever he wants to run both batteries, all he has to do is just pop that other battery in there. No extra charging needed to get it up to the same electricity or anything. Just put that battery on there and go. Simple as that. So this one I designed where this goes inside of the tube. All the wires and everything fit in here. It lines up with a little screw. I'm probably going to put some clear tape over that so it doesn't rub off, so it's easy to align where the screw hole is, like how that is, which matches up with that. But that's the rundown of phase 2 of my ATS switch. This is the modified. I had been using the original ATS switch for about a year, and that original ATS switch basically had the problems after about 8 months of use where the board would just get too hot. And it turns out it's simply because I'm running, you know, between, let's say at max 42 volts through this system, and this 10 amp circuitry board setup just couldn't handle it. It just would get hot, and eventually it got hot to the point that the solder points would melt. It dropped out a capacitor, had to solder that in. It dropped out a diode, had to solder that back in, and then finally it blew the diode. So it's like, okay, fine, let's rebuild, let's do something different. And the best way of thinking of is use the ATS switch original board, which is like $7-8 off of Amazon, modify it by getting a 30 amp relay and using that to handle all the electricity, using the ATS switch to handle the switching, and voila, you got a nice little setup here. This video is also a reminder for myself of how I have everything wired in. The only wire that's not removable is this one. All the others have disconnects, and disconnects. Alright, so once again the reminder, from the trigger point, which is your 5-volt trigger on your relay, take it out of the board, which would have been the trigger point, and run it into the external relay. Get rid of the original blue relay that was on here. You're not going to need it anymore. You can pretty much get rid of your input pieces and your output pieces. You definitely don't need the output piece because now you're outputting from the relay, not from the board anymore, so you can just take that piece off. All your negatives are bound together. So there's a board you can't see because I've got the silicone over here, which is my strengthening for my wires so they're not always moving around. But I've got my negatives all on basically a bus if you think about it, but the wire is the bus. This is my bus point for all of my negatives. Alright, simple setup, right? Under the bottom I basically use zip ties to connect the boards together, my extension board, and then I made a connecting bus with solder and wire, and then protected that with the silicone so they don't touch anything and short out. Alright, I think that pretty much is good enough. And oh yeah, again, the unit that I'm using, SLC 0.5 volts DC, SL, if I remember correctly, -C. SL-C. So SLC 5 volt DC, so my coil is 5 volts, and it's an SLC. All right.